Hi students, in this video I am going to discussing about differentiability for class 12 students. This chapter carries 16 marks. It is also one of the important chapter for class 12. So now differentiability concept was first introduced by two mathematicians. One person is Isaac Newton and Leibniz in the year 1887. Now coming to in the continuity differentiability, what you learn in the concept of continuity for class 12, left limit and again right limit for the function and again limit of a function, continuity of a function. So now in this class we will learn differentiability or differentiation at a particular point at the function. The definition of a differentiation or differentiability is given by here. The process of finding the derivative of a function is called differentiation or differentiability. The process of finding the derivative of a function is called differentiation or differentiability. So now let us consider one function. Let y is equal to f of x be a real valued function. And C is a point in its domain. Then the derivative of f, at x equal to c or x equal to a, you can take any one, x equal to c. If x equal to c, then the derivative of the function is always denoted by dy by dx at x equal to c, or it is denoted f dash of c, which is equal to limit h tends to 0 f of c plus h minus f of c divided by h. Already you learned in the class 11th differentiability. F dash of a is equal to limit h tends to f of a plus h minus f of a by h. Same thing. When you take x equal to c, f dash of c equal to limit h tends to 0, f of c plus h minus f of c divided by h. Or you can write as put x is equal to c plus h. Put x is equal to c plus h. As h tends to 0, then x approaches to c. You can write as f dash of c, which is equal to limit x tends to c f of x minus f of c divided by x minus c. What is h value? H is nothing but x minus c. X is equal to nothing but c plus h. C plus h is equal to x minus f of c divided by h is nothing but h is equal to x minus c. This value must be finite and also exist. Limit must be exist and also finite. This form is nothing but the another form of the derivative of the function. This is one direct standard form. This is the another form. Both are same. By taking the values of x is equal to c plus h. Here x tends to 0, here x tends to c. Both are same. You can use any one formula. You will get the answer for the upcoming problems. So now, as per the continuity of a function, you learn limit of a continuity of a function, left limit and again right limit particular point. So same thing here. Left derivative and also right derivative. We have two definitions. Left derivative and also right derivative. So what is left derivative? Left derivative left derivative of a function. Left derivative is always denoted by capital L. F dash of c, which is equal to, I am taking this condition. So limit x tends to c minus, left derivative means left side of the point c, x tends to c minus f of x minus f of c upon x minus c, which is equal to, when changing the limit value x tends to c minus, we have taken one positive real number h. So limit h tends to 0, h tends to 0, put x is equal to c minus h, f of c minus h minus f of c divided by c minus h minus c plus c minus c, both cancel. You can write as limit h tends to 0, f of c minus h minus f of c upon minus h. This is the left derivative of the function. According to, I am not taking new thing. According to this formula, you can take this one and again this one, you will get the same answer. This is also finite value and also exists. Same thing, right derivative of the function. Right derivative of the function. Right derivative of the function, it is always denoted by capital R, f dash of c, which is equal to limit x tends to c plus f of x minus f of c upon x minus c. Here what we are taking, x is equal to c minus h. Same thing here, x is equal to c plus, because right side of the point c plus. So we can write as it is equal to, limit also changes, h tends to 0, f of c plus h minus f of c upon x plus, c plus h minus c plus c minus c cancel. You will get the answer which is equal to limit h tends to 0, f of c plus h minus f of c divided by h, f of c divided by h. Observe, this is the left hand derivative, this is the right hand derivative. Limit h tends to 0, f of c plus h minus f of c divided by h. This is also finite value, this is also finite value. When the derivative of the function f at x is equal to c exists, means left derivative value and also right derivative value must be equal. Left derivative and also right derivative must be equal. Then only the derivative of the function exists. If left derivative and right derivative not equal, we can say clearly if the function is not differentiable at x equal to c. Remember, here I am taking x is equal to c. X is equal to c. In place of c, you can take a also. Because x is equal to c, you can take x equal to a, f dash of a, here also f dash of a, here also f dash of a. Instead of c, you can write a also, because it is also one of the point. So now, here, according to the derivative of a function, what we say here, left derivative of a function is equal to right derivative of a function. That is nothing but what? Limit h tends to 0, f of c minus h minus f of c divided by minus h is equal to right derivative limit h tends to 0, f of c plus h minus f of c divided by h. Both are finite values. When the derivative of function must be exist, means these two values must be equal. Then only it is possible. If it is not equal, left derivative of the function at x equal to c, right derivative of the function at x equal to c, which is not equal, what we say here, left derivative and right derivative is not equal. The function is not differentiable at x is equal to c. For suppose left derivative of c at x is equal to c, right derivative of c, if both values are not equal, you can say f is not differentiable. F is not differentiable at x equal to c. For suppose the derivative of the function f at x equal to a, you can say f is not differentiable at x equal to a. So next, one, geometrical interpretation of the function. Geometrical interpretation of the derivative of a function. So now I am taking x coordinate and again y coordinate, geometrical interpretation, x coordinate and y coordinate. For suppose this is the curve y is equal to f of x curve, y is equal to f of x is a function, y is equal to f of x. I am taking one point on the x axis, this is equal to c, at x is equal to c, at x is equal to c. This is the point, what we say, this is the point P. Let us take this is the point P. What is x coordinate, x is equal to c, and again y coordinate, y is equal to f of x, nothing but what? X is equal to c. You can write y plus, how can you write f of c? Y is equal to f of c. Once again, on the x axis I am taking a, I am taking this is the domain value in the particular interval c in the point P. X coordinate is equal to c, y coordinate how much? F of x. X is equal to c. You can write as c comma f of c. Next one, right limit of the value I am taking, this is c plus h. When h tends to 0, it will be c, and h is a one small real number, c plus h we can say. So this is equal to r. What you write here? C plus h, x value c plus h comma f of c plus h, one value, f of c plus h, this is one value, f of c. Next one, left side of the point, this is c minus h, this is the point is q, so what you write here, this point is c minus h comma, and again f of c minus h. So three types of points. So what we understood in this, we have to find out slope of this chord, line joining the points, PQ. So slope of PQ is equal to, this is x1 by 1, x2 by 2. So what you can write as f of x2 means f of c minus h, x2 minus x1, f of c divided by x1 by 1, x2 by 2, y2 minus y1 is f of c divided by x minus divided by x2 minus x1. So we can write as f of c minus h minus f of c divided by plus c minus c cancel, it is equal to minus h. So slope of PQ is nothing but t here. Tangent of this PQ, this is when h is approaches to 0, when h value is approaches to 0, this value becomes, this point is closest to P. When h tends to 0, this point becomes P, that is Q becomes P. So these two are equal, Q tends to P. So tangent at P, which is equal to, you can write as f of c minus h minus f of c divided by minus h. When you apply limit h tends to 0, f of c minus h minus f of c divided by minus h. So this is the point PQ. Same thing here. Slope of PR, which is equal to, we have to find out slope of PR. Chord joining between P and R is equal to x. This is x1 by 1, x2 by 2. Is y2 minus y1. F of c plus h minus f of c divided by c plus h. That means x2 minus x1, which is equal to f of c plus h minus f of c divided by plus c minus cancel, which is equal to h. So slope of p are also finite. Slope of pq also finite. Here, when h tends to 0, r is closest to p. When h tends to 0, this value 0, it becomes p point. So slope of pq is equal to slope of pr. So we will get tangent. One tangent at a point drawn. So tangent at p is equal to f of c plus h minus f of c divided by h when limit h tends to 0. Tangent at p, because both are same. So slope of pq and again slope of p are coincidence at point p. Because when x tends to 0, here also x tends to 0. These 2 points coincide at p. We can say unit tangent at p. The tangent of the derivative of the function drawn at p. So left limit, this is the left limit of the function, this is the right limit of the function at c. So this is the point p, coincidence at p. You can say this is the left derivative of the function, this is the right derivative of the function.